Google just quietly published research that could change the economics of AI completely. It's called TurboQuant, and the numbers are almost hard to believe. 6 times less memory, 8 times faster performance, with no loss in quality. If that holds up, it's one of the most important AI efficiency breakthroughs in years. Here's what it is, why it matters, and what it means for the cost of running AI. First, a quick explanation of the problem it solves. Every time a large language model like ChatGPT or Gemini processes text, it builds something called a key value cache. Think of it as a working memory, a digital cheat sheet the model keeps open while it's generating a response. It stores context, relationships between words, and semantic meaning, so the model doesn't have to recompute everything from scratch on every step. The problem is that this cache is enormous. Large AI models can require hundreds of gigabytes of memory just for this cache alone. That memory is expensive. It's one of the biggest costs in running AI at scale. And RAM prices have been soaring because every AI company is competing for the same chips. The standard fix is something called quantization, compressing the data in the cache to take up less space. But the trade-off has always been that compression hurts quality. You save memory, but your outputs get worse. TurboQuant breaks that trade-off. Google's algorithm uses a new approach to vector compression, specifically targeting the KV cache, that achieves extreme compression without the quality loss. In their tests, 6 times smaller memory footprint, 8 times faster processing, and accuracy that holds up on standard benchmarks. TechCrunch compared it to Pied Piper, the fictional compression algorithm from the TV show Silicon Valley. The joke is apt. In the show, a startup invents compression so good it seems impossible. People in the industry are having that same reaction to TurboQuant. Here's why this matters beyond the technical details. Right now, running frontier AI models is extraordinarily expensive. A single inference, one response from a large model, can cost fractions of a cent at scale. But when you're processing billions of requests, those fractions add up to billions of dollars. The main bottleneck is memory bandwidth. You need fast, large, expensive memory to run these models in real time. TurboQuant cuts that requirement by a factor of 6. That means you can run the same model on hardware that costs a sixth as much, or run a model 6 times larger on the same hardware, or serve 6 times more users without adding infrastructure. VentureBeat is reporting that TurboQuant could cut AI inference costs by 50% or more. That's not a marginal improvement, that's a structural shift in the economics of the entire industry. It also has major implications for the environmental story we covered earlier this week. If AI models need 6 times less memory to run at the same quality, that directly reduces the energy and water consumption of data centers. The two stories connect. Google is presenting TurboQuant at the ICLR 2026 conference, one of the top machine learning research conferences in the world. The research is public, other companies can implement it. This isn't a Google-exclusive moat, it's a contribution to the field. The internet is already calling it the Pied Piper moment. Whether it lives up to that in production, at real scale, on real tasks, remains to be seen. But the early results are genuinely remarkable. 6 times less memory, 8 times faster, no quality loss. That's the kind of breakthrough that only happens a few times a decade.